Welcome back, guys. Welcome back. Now let's move on into our fifth lesson of the course. At this point, we're no longer focusing, or we're not strictly focusing on descriptive statistics, because this can be used both partially as descriptive and partially as inferential statistics. So the z-scores, there's different interpretations for what is the z-score. For me, to keep it super simple, I think of a z-score as a standard score. Standard scores, as I've already put it on the slides, allows for a more fair comparison. If you have one specific score and you have, say, on an exam you have an 80 that you scored on an exam, but you have two different populations, or you have two different samples, an 80 can mean very different things on both samples. I bring this up, say for example, that there was one class, remember, in middle school, where on a test, a physics test that was super hard, I ended up getting like a, not even a 60, like a 58. And I was so disappointed because I got like a 58 and I thought I had failed the class, but it turned out that everyone in that class failed, and my 58 was actually the second highest grade in the whole class. If you put the grades in its right context, if you put a number in the right context, you can understand much more from it. So z-scores allow for a more fair comparison across two, like a specific number from two different samples. As long as you know the mean and the standard deviation, you can compute any number into a z-score. So let's review. To put up an example, we want to think of the IQ. Overall, research based on the IQ states that on average, our IQ, our intelligence quotients, the kind of number that predicts how much information can we retain, is about 100 with a standard deviation of 15. So let's put up an example. If we have X is for a specific score that you have in mind, you subtract from this number the mean and you divide it by the standard deviation, you would be able to get any number into a z-score. Let's say that you took a z-test, and in the z-test, I'm sorry, you took an IQ test, and in the IQ test you got 105. The 105 that you got is going to be subtracted from 100, which is the sample, the mean from the sample, and you're going to divide it by the standard deviation. That's going to give you a z-score of a 0.33. If, say, a friend of yours takes a similar IQ test with different numbers, this is the most common, like the basic, the standard IQ test. But there's other types of intelligence tests that don't give out 100 as an average. There's other kinds of tests that give out like a 50 as an average. So if your friend over there got a 45 with a mean of a 50, how can you possibly think or know if one did better than the other? Well, that 45 is going to be taken with the 50 from the mean from that sample, divided by standard deviation for that sample, and that's going to give a z-score, and then you make a comparison among two z-scores, and that's going to be able to give you a more fair comparison to say who did better. Z-scores can be used to describe a specific number in the data, or z-scores can also be used to infer something from the data. So it can partially be also going its way into inferential statistics. Now, as long as you know the mean and the standard deviation, you can compute any number into a z-score. But if on the other hand, you already have a z-score in mind, based on that z-score, you can also find a raw score. So this formula is if you want to find a specific raw score. Say that you work for the admissions department at a prestigious school, and you want, because of all the information that you're getting from applicants to the school, you say that you're going to admit only those students that are on the 1.5 z-score range. So what you're going to put up here, 1.5, that is your interest in a z-score, and it's going to be multiplied by the standard deviation, and then you're going to add the mean. So that 1.5 multiplied by 15. Cool. And then for a z-score of 1.5, according to the sample mean and the sample standard deviation, will give you a raw score of 122.5. The IQ score that will give us a z-score of 1.5 is going to be 122.5. Now, it may also be possible that you're looking at a number that is below the mean. If that's the case, then you will look into perhaps going into the negative realm. Let's think of an example there. Let's say that instead of 105 here, let's say that you took the test, the IQ test, and you were scoring below 100, you get a 90. This is going to take us into the negative numbers because it's going to be then 90 minus 100 is going to be minus 10 divided by 15. So it's going to give us a z-score of minus 0.67. A z-score that is in the negative realm implies that it's going below the average, went below the mean. Alright, let's say now that instead you're looking at the bottom of the people that took the exam. So say instead of 1.5, you went into the negative realm. Minus 1.5. So you want to know what is the z-score of the people that were all the way to the bottom. Minus 1.5 multiplied by 15 is going to be a negative 22.5. And if that negative 22.5 is added to 100, it's going to take the number below. So that's going to give us a cool, simple stuff. That's the z-score. What becomes a little bit tricky though, the use of the z-score is especially useful when you're trying to find a percentile. So now let's go into that. Now this is the challenging part. This is going to be the challenging part in the z-scores. Based on my experience, students have no difficulty understanding the use of the z-scores, and students don't have that much difficulty knowing how to differentiate the formula from a z-score to a raw score. Again, as long as you know what the question is being asked, and as long as you know the usefulness of it, which is to compare in a more fair way groups, then it's pretty easy. But the thing that is somewhat difficult is how can you use it for a percentile? So you want to go into the unit normal table. As you watch this part of the video right now, make sure that you open that one so you can see that table and you can reference the video and you can reference the table and you can look at both back and forth. The unit normal table is based off a normal distribution of scores, which is the bell-shaped curve that goes like that. There's some things that go beyond my knowledge because it's realm, like this is a realm that goes deep into mathematics. So just to keep it super simple, there are mathematical rules that we abide, that we go by. So mathematicians theoretically predicted that as long as you get data from a population, you typically will see a distribution of scores resembling this. Most scores tend to be at the middle, and fewer scores go at the end. What you see here on this end is going to be the lower end, and what you see here over here is a higher end. The numbers that you see on the unit normal distribution table is based off numerically how this looks like. So we can use it to find a percentile. Say, in the table that you have, there's three columns. There's column A, and column A is giving you the z-scores. Column B is giving you information from the mean. The mean is right in the middle. From the mean to the z-value. And the column C is giving you information from the mean to the infinity. You'll get more comfortable with it with time, but you do need to make an effort here because it may be somewhat confusing. Look, I'll try to make it as simple as possible. The thing is, when you want to look for a percentile that is less than 50%, you go into the C column. You look into the C column when you go for something that is less than 50%. So let's think of an example. Say that you're interested, based on the same numbers that we have here, you're interested in finding a percentile of something less than 50%, something like 40%. So you wonder, what is the score at a 40th percentile? So you're going to look into the table for the value that is closest to 0.40. Into the C column to the value that is close to 0.40. That is going to be in the C column, and then in there you're going to find the Z-score, and you're going to plug it here. Stop the video right now. Stop the video and look into the unit normal table to find that value, and then come back to me. If you found it, if you stop the video and you found it, what's the value? The value is, the Z-score is the one that we're looking at. So look at the C column for the value that is closest to 0.40. And it's going to be 0.25. It's the Z value. And you will find the Z value in the A column. However, there's one thing here. Because we're looking at something that is less than 50%, in essence, in the table, visually, you're at a Z-score that is going below the mean. The C column is giving you this, the percentage of people that are below you. The number goes under the 0, so this should be a negative. So in the formula, it's actually a negative 0.25. And that's the rule that you want to remember. Every time that you look for a percentile that is less than 50, you're going to go into the C column, and once you find the Z-score, you're going to transform it into a negative Z-score. So let's do it. Negative 0.25 multiplied by 15 plus 100. And what do you get? You get a 96.25. So, according to this data, if you get a 96.25, that's going to give you a percentile of 40%, meaning that you're above 40% of the people that are taking the IQ test. Cool? That's finding a percentile based off something that is less than 50. How do you find the percentile of something that is bigger than 50? So, let's do another example. Let's say now that instead of looking at something that is less than 50, we're looking at something that is over 50. So let's think of an 80%. A percentile of 80. When you're going to look at something that goes over 50, now you're going to go into the B column. So the B column is used something that is more . However, here's the trick. Watch out, pay attention. The V column, say that is here. The V column is giving you information from this point to the middle. So this is what the B column is giving you. This. Alright? But at this point in the mean, when you have a Z-score of 0, everything that you see on this side over here is 50%. So that 50% is already given to you. The only thing that you need to look for is for what is remaining here. So, if say in this case we're looking at an 80, right? What we look into the B column is not going to be for an 80, because we're going to subtract 50 that is already given to us here. So what we're going to look for is the remaining, which is a 30. So, at this point, stop the video right now and go into the unit normal table, and in the V column, look for the value that is closest to 0.30. Alright, go. Notice here, because this one is going to be tricky. You have two options technically. You have a 0.84 as a z-score or a 0.85. However, which one of those two is closest to 0.30? Even though it's a couple numbers below, but actually the number that is closest is a 0.84. Here you're going to put in 84. That's the z-score. So we're going to multiply 0.84 by 15 plus 100. And we get 112.6. So, according to the rules, based on the normal distribution of scores, if you get an IQ score of 112.6, it would result in a percentile that is at 80%. So 80% of the population are below you if you get a score of 112.6. This is kind of the tricky thing, so you want to make sure that you write down the rules. If you're looking for something that is less than 50, go into the C column and look straight up for the number. Just remember to make the z-score negative. And if you're looking for something that is over 50, then just remember to subtract 50 from the number that you're looking for, and then what is remaining is the number that you're going to be looking for on the B column. And that's it. Percentiles are very efficient and easy to use as long as you have a mean and standard deviation. Based on the z-scores, you can find any percentiles. That's the use of the z-scores. Good work.